Hello, sixth grade. This is Miss Petty giving you guys a lesson on statistics. We're going to start our newest module, which is statistics. I hope everybody is well. This lesson is going to coincide with Teacher Toolbox Lesson 26, and it will be split into two videos. Our lesson objectives are understand that data generated from a statistical question will vary, recognize that responses to statistical questions have variations that can be used to draw conclusions about the data set, identify the difference between a statistical question and a non-statistical question, write sample statistical questions, and create models that represent the data from statistical questions such as charts and tables. So our first part of the lesson is actually going to be a prerequisite skill, and that skill is I need to use this. That skill is line line plot. So how can you use a line plot to interpret data? What have I done? Okay. So everyone should have access to this packet. If you don't, go ahead and let me know and I can get it to you ASAP. So here's our example. As you guys know, I usually do the example and answer those questions, and then I expect everyone to answer the questions themselves on the next page, and then we usually come together and make sure that they're right as a class. So, starting with our example. Anna planted radish seeds in her vegetable garden. At the end of 2 weeks, she measured the height of each radish plant to the nearest half inch and recorded her data in a table. How can Anna show this data in a line plot? Now, so before we go on, think about what a line plot is and how you've made one before. For people who don't remember, don't worry, we're going to the next thing. So, moving forward, mark an X to stand for each plant in the table. Very important. That's what we do for line plots. So we have a table, we will have some values, and then we will have how many. So we're just, so I'll call it V for values, and then the H over here for how many of each value. So look, for example, the line plot below shows that 2 plants were a half inch tall. The way that they get that is first they look at the table. The first thing, our first value here is 1/2 inch, and they know that 2 plants are a half inch tall, so they came over here and they made 2 X's. So if you guys were supposed to make a line plot, this is what you would do. So you would go to the next part in the table, 1/2 inch, and then you would make 3 X's. Make sure you ask questions if you don't recall any of this, and we can get further in depth. So, review the table, and we are going to go on down. Fit it all in here. Yeah. How can you use the line plot to tell how many plants are 2 inches tall? This is a very interesting one. I love these questions, of course. So, what I would do is I would look for 2 inches. And we have that. And I would just count the X's. So you should do the same thing. Look for 2 inches in the table and count the X's. and I count 8 x's. Number 2, consider how the data in the line plot is clustered. What does the line plot say about the plant height? So instead of looking at just one thing now, I need to look at all of the data. And then our keyword for the question is clustered. So clustered means kind of together. So how are they together? So I'm going to just highlight around the majority of our plants, and a majority of them are clustered around the 2. The range there is between 1.5 and 2.5 inches. So I would say that the majority of the plants are about 2 inches. Well, actually, the majority of the plants are 2 inches, and they're clustered around the 2. So most likely, if I planted a radish plant, I would think that the plant would be about 2 inches tall, maybe 2.5, maybe 1.5. But anything beyond that is going to be a funny plant. Maybe it overgrew or undergrew. Who knows? Yeah. And these are our wonderful independent questions. So take a moment, pause this video, and try to work them out yourself. And then come back to it. All right, guys, welcome back. So here are our independent questions, and now I will work them out. Colton puts grapes in a plastic bag to sell at the farmer's market. He weighs each bag and records the weight in the line plot below. There's our line plot. Over here. Now, so what is the difference in the weight between the heaviest bag and the lightest bag? Where did you find out what the heaviest bag was and the lightest bag was on this table? Go ahead and highlight it or circle it, depending on what you guys have in front of you. I am going to circle. I believe that the heaviest bag, the lightest bag, I believe the heaviest bag is 2 pounds, just because it is the furthest to the right. And the lightest bag is 1/2 of a pound, just because it's the furthest to the left on my table. Now, here's another keyword we're going to need to look for. Difference. When you see the word difference, the operation that you should think of is subtraction. It totally says subtract. So when you see the word difference, subtract. So we're going to take the heaviest bag and subtract the lightest bag. So 2 minus 1/2. Now take a minute. If you didn't have that at first, correct yourself. If you did, good job. So in order to subtract 1/2 from 2, I would convert 2 into a fraction. That would just be the quickest way for me. So 4/2 minus 1/2. Now that I have 2 fractions, I could just subtract the numerators. And that should give me 3/2. And anytime we have a fraction, we should always we should simplify it or write it as a mixed number in the end. If this was a multiple choice question, you could get a number of ways. You can get a number of answers. So the answer I would expect to see is 1 1/2. But sometimes they would give us 1.5. Or, depending on if they really want to trick you, 3/2. Like we got in the beginning. So that's our solution. Number 4. How many bags of grapes weigh more than 1 pound and less than 2 pounds? This sounds like an inequality to me. So, keywords, how many? More than 1 pound and less than 2 pounds. I am going to look at the number line that we have for our line plot, and I will plot these inequalities before I do anything else. So, more than and less than, there are no equal signs, so that means open circles. And then, of course, we're going to go between, because it's more than 1 but less than 2. So, we're not including our 1 pound or our 2 pounds. They're not there because those circles are open. So the only thing that we would include is 1 1/4 pounds and 1 1/2 pounds. If there were any excess over the 1 3/4 pounds, we would use that as well. So just count the X's and what do you get? And while you guys think about that, if your answer was wrong, make sure you correct yourself. Make sure you know why. If this is a 10, not a 16. Yeah, I'll just write it over. It is definitely a 10. So if you don't know why it's 10, shoot me a message and we will get further into that. Number 5. Describe 2 different ways that a customer could buy 4 1/4 pounds of grapes. Now, this is an answer that is definitely going to vary, and you can answer it however you want to. I will highlight a few different ways, and you guys can tell me if you got the same way or a different way. First way, I would do 2 pounds, 1 1/4 pounds, and a 1 pound. And if I added those up, I would get 4 1/4 pounds. The second way, I just like to use all these colors. I think I will use 1 1/4 pounds in nearly every way just because it seems to be the easiest way. 1 1/4. So this would make 2 1/4. And then 4. There are so many different ways you can do it. So don't worry if your way doesn't add up to mine, as long as when you add up all of your bags, you have 4 1/4 pounds. And it's time for us to move on to our challenge question. While I erase. This is really like being in the classroom. We try to erase the board while so you guys to change the page. So now, Greg wants to buy 2 bags of grapes that have a total weight of 3 3/4 pounds. Is there a way that he can do this? Explain how you know. Look very, very carefully at your line chart. You are trying to get 3 3/4 pounds. Using 2 bags. So if there is a way you can do that, let me know. So this is a yes or no question, and you will explain your answer. I am going to actually leave that one up to you guys to think about, but I will tell you that the answer is nay. He could not do it. That's what I believe. If you find a way, let me know. Number 7, describe a different set of data that you could display on a line plot. This is a very, very good question. I'm also going to leave this one up to you guys, just because it is a great opening question for the next part of this lesson. Um, I will leave you with an example. What are the ages of your classmates? That one is a really, really big one. We have at least 3 years between us in the class. Sometimes there are people who were born early, sometimes people that got born late, and then you have people that were born right on time to start school at a certain time. So there could be a range of ages in the class. Now think about why I said that, because we have a range of ages, and that would be data that we can display on a line plot. So think about that as we go to the next part of our lesson. As always, if you have any questions, feel free to contact me via Class Dojo or email. Right? Have a wonderful day. Yeah. End it.